And this our focus is to provide future 6G connectivity. So we are focusing on this multi-granular packet optical X-Hall transport network for 6G. So once said that, let's take a look at what is being developed in the optical layer for these networks. This is what we call the multi-granular optical node. It's based on a 3-layer architecture. First, layer 1, we can see that we are flexible band route and select with waveband wavelength selective switches, which allow us to filter different band switching levels, including full spectrum fiber switching. So once this at layer 2, we are able to provide flexiband and add drops. Then this is thanks to the interband optical cross connect. And finally, at layer 3, we are providing access to individual wavelength for routing and add drops. So using different wavelet selective switches equipment operating at different bands. We are operating right now at CL and S bands. This is the architecture that FlexScale proposes for end-to-end management of RAN, core, and network and transport domains. So if we take a look at it, you can see that we have the 6G management system on the left side, the end-to-end transport orchestrator like TeraFlowSDN, and then we can have different kind of controllers, the optical controller that below, and the packet SDN controller for the layer 3 routers. This allows us to interconnect the different 5G radio units to the DU, CU, and finally the core networks. Also, we are looking for different functional splits where we can have even UPF at the MEC computing side. Okay, and then let's take a look at how we manage IP-over-DWDM networks. So you see this layered approach. We have the waveband layer, the wavelength layer, and finally the IP layer. And if we are intending to go from A to C, you are seeing here how we are need to create a virtual link at each layer and then offering it at the higher layer. So in this case, A to E, we see that the different channels need to be activated. And then we are able to connect the routers. How are doing this? We are doing with different functionalities that we have been developing them in TeraFlowSDN with release 4 and 5. You can see that we are. Let me do one thing. Okay. So we see the multi-granular optical support that has been implemented in the optical controller. You can see the automation closed loop that we have already presented before with Wallet. Then on top at the orchestration layer, you can see how we are working with different parameters to tune efficiency, such as energy, add multi-layer support for packet and optical. So these are the different functionalities. And if you remember, we had a TFS orchestrator working on top of multiple SDN controllers. In this case, all the different controllers are based on TeraFlowSDN, but with different flavors. One is the optical SDN controller, which basically focuses on the control of optical devices. We have the IP SDN controller, which is able to handle the white boxes. And then on top, we have the end-to-end SDN orchestrator, which allows us to control the different controllers. So this is one of the demos that we did at. I have some delay, and it's very annoying. Sorry, now it's fine, I think. So this is the OFC demo that we presented at the OFC this year. In it, you can see the end-to-end IP domains and then the optical domain, which was located in HHI in Germany. So you can see how we were able to handle. Is someone in this? I think that you all can hear me well. Okay, so let's continue in this way. Sorry for that. You see the architecture of the demo that we presented, handling both IP and optical domains. And now we are focusing on the access of the network. Remember that we have different scenarios. This is we are doing functional splitting in the front hall and in the mid hall. But we want to resolve one question. Who should control the optical pluggables? Because in this case, what we are seeing is that every time more we have white boxes, IP routers, which are able to directly tune the pluggables, to directly sham to the optical network. So the network that we have seen previously is being simplified. As you can see, we have now only two different hierarchies. And for this, we don't know in this kind of architecture who should be responsible for each of the elements. So we have the IP controller and the optical controller, and there are several pros and cons for each one. The pros for the IP controller is that it already manages the IP router, but it doesn't have the visibility of the different wavelengths to be tuned. So he needs to talk with the OLS at least to have the information. Then we have the optical controller, which has full awareness of what's happening at the optical layer, but doesn't know anything on the different IP routers, which are typically the ones that you need to access to configure the pluggables. So this leads us to some need for describing which shall be the controlling mechanism. And as academics, we are looking at what industry is proposing, and there are four different ways of doing this. Not just two of them, but four of them. The first one is proposed by ATF, and it talks about dual southbound interface management of the IP over the DWDM routers, with IP and optical controllers having read and write access to the pluggables, meaning that everyone can modify the configuration of the pluggables, either IP layer or optical layer. This has some benefits and or problems that I will describe later. Then the second one is to have a single southbound interface management for the IP-over-DWDM control routers using the tip mantra. So IP controller manages everything, and you forget about that. Then there is also a dual SBI management of the IP over the WDM routers, with the optical controller having only read-only access to the transponders. That's also suggested by tip mantra. This means that the optical controller can have information from the pluggables, but the responsible for writing new configuration is the IP layer. And finally, there's a fourth way of doing things, that let's just create a new SDN controller, which is the pluggable controller. This doesn't align a lot with industry, because we have seen in industry two trends in the IP or optical world, but to have a new third trend might be difficult to succeed. So, as I said, the first one brings some out of sync problems. The second one increases complexity, as it needs to convey information on the pluggables on the optical SDN controllers. The fourth one, it increases complexity at the AP layer, because it's responsible of the configuration of the pluggables. And the fourth one requires this new dedicated controller. We think, if you ask us, that the feasible solution and the more aligned with industry might be the the dual southbound interface management proposed by TipMantra. So let's take a look at the two different options that TipMantra is proposing. This is the single SBI management of the IP-over-DWDM routers. I will fly through it, to be honest, because I think that the information is on the slides, but you don't need to have all the details unless that you are very interested. And this is also how service computation is performed at the orchestration layer. And this is what I was saying, that this is how we understand that it might be the best solution for the management of IP over the WDM routers being aligned with TipMantra. So remember, IP controller has read-write access to the transponders. The optical controller has only read-only access to them. So in this case, the pluggable discovery of the capabilities can be done by the optical controller. This allows the optical controller, the optical line system, to have include the pluggable information. Then this allows the IP over the orchestrator to create the planning request. Then the computation of the pluggable and media channel is performed at optical controller layer. This gives a response. Then there is a media channel request that allows to configure the different OLSs. Then we are able to configure the pluggables at the IP controller layer using the RESTconf OpenConfig protocols, including the different central frequency, output powers, operational modes, and so. Then we are able to configure the IP link configuration at the IP layer. Then we are configuring the packet flow, and finally we configure the IP routers. So this is the mechanism described by TipMantra that we think it's more aligned with industry. In this slide, we also show how failure management is performed. I will not go into depth into all the details, but I wanted to give you some key takeaways of this talk, which allow us to coordinate this challenge. We think that there is no ideal solution. There are different trade-offs. This complexity arises because of three different key operations: the discovery of the pluggable capacities, the computation of the pluggable configuration, which requires OLS information, and finally the configuration of the pluggables. So we need a tight coordination, we need orchestration, and that's what we are researching in the Proteus and FlexScale projects. So we are right now analyzing all the needs for extending TeraFlowSDN framework to support this pluggable configuration. Right now, we are able to support IP or optical and to orchestrate on top. Now we need to rethink some of the components and maybe include new ones to handle this pluggable complexity. And this is some of the work that the Proteus 6E project will be doing in the next releases. So that's all, and thank you all for your questions. Georgios. I'm not the expert, you know. Okay.
And our work as well. I'm wondering maybe how we could combine what Nico presented earlier for the Proteus project. We have the ORAN SMO, we have the TeraFlow controller with the ITF, right? And eventually we need to basically control both IP and optical. In our demo, we didn't have optical because we are not doing this kind of work, but you do. So I guess we need to integrate somehow, right? Let's say our field efficiency to keep some either real optical devices or emulated ones, I don't know, to basically meet the need for the Proteus project.
Yes.
But eventually this needs to go down to the optical work, right? So
We will need to go through orchestration. So for you, it should be seamless in somehow, in the sense that you request a slice service, which now will be processed as NSC, and then this requires some layer 3 VPN configuration. And from there, you have all the end-to-end orchestrator component, which should handle all the necessary below. Yeah.
And another optical.
Exactly.
Underneath. So, yeah.
I think that's the next further work for the Proteus project. It's like this. I'm not able to talk much about Proteus project specifically because I have not synced with Raul or Luis. So maybe you are more aware of the project. Exactly. Thanks a lot. And okay, so that's the